square root of 2 in exponent square root of 8 divided by square root of 32 in exponent square root of 2. So let me rewrite this expression. So we have here 2 in exponent square root of 8. Everything is divided by a square root of 32 in exponent square root of 2. What we can do here now, we can write this square root of 8, we can write as 4 times 2. And now down here, square root of 32, we can write as 16 times 2. So we can write 16 times 2 in exponent square root of 2. And now, if we are simplifying a little bit here this exponent 4 times 2, we can write in this form. Square root of 2 is times 2 here, square root of 2, because square root of 4 is 2. And 2 stays under the square root of 2. And here in the denominator, square root of 16 is equal with 4. And I can write here times square root of 2, everything is in square root of 2. And now we can simplify a little bit further. But first of all, here let me simplify this power 2 with the index 2. And what do we have here on the numerator? We have 2 in exponent square root of 2. In the denominator here, we can write this 4 as a 2 square. So let me write here 2 square times square root of 2. Everything here we can write under the square with the power square root of 2. So now, if we can distribute this square root of 2 in both sides, in both of those terms in denominator, we can get as follows. 2 in exponent square root of 2, and here we have 2 times, we have a square root of 2 times 2. And here is a square root of 2, everything is in exponent square root of 2. So we have this situation. But now, since I have the 2 in exponent 2 square root of 2, I can take the reciprocal here. And if I'm taking reciprocal, or if I am obeying the rule that is a in exponent 1, a in m in x is equal with 1 over a minus m. Or in other words, if I'm taking shortcut, if I am switching the position of one number from a numerator to denominator or vice versa, the exponent is going to change the sign. So what we are going here to do, we can write this 2 in exponent square root of 2 times 2 in a minus 2 square root of 2. And in denominator stands square root of 2, everything here is in square root of 2. But since, according to the exponents rules, since I have the base 2, we can write the base 2 and we can add the power, which is the square root of 2 is a minus 2 times square root of 2. And here down, I can write square root of 2 in exponent square root of 2. What I can write further? Further, if I'm adding those radicals, we can write 2. Square root of 2 minus 2 times square root of 2 is a minus square root of 2. Divided by square root of 2, everything is in exponent square root of 2. As I mentioned before, now this one, if I am changing the position from numerator to denominator, we can change the sign of the power. And this becomes in this form. 1 over 2 in exponent square root of 2, so I have this one here, time, what do I have here? I have a square root of 2 in exponent square root of 2. So it looks a little bit nasty, but we can simplify a little bit further. And here we can write as a 2 times square root of 2 in exponent square root of 2. And now this square root of 2, so let me simplify a little bit further. This I can write as a 2 times in exponent 1, and this square root of 2 we can write in a fraction, in a rational exponent as 1 over 2, because I want to make the same base and I want to multiply these two terms. Everything is in exponent square root of 2. If I am multiplying, Now this one we can write as a base 2, and we add in exponents is 1 plus 1.5. And everything here is a square root of 2 in 1. And 1 plus 1.5 is 3 over 2. Okay, to make a little bit more simple, so this one is 1 divided by 2 in exponent 3 over 2, and everything here is in exponent square root of 2. And if we are distributing this square root of 2 inside of this power, we get 1 is divided by 2 is 3 times square root of 2 divided by 2. And I would say this is a final result. We can simplify more, but I think this one satisfies this result what we were trying to find.